Okay, let's see what we've got here. Right. There we go. It's a bit hard to see this font. Z bar is the complex conjugate of Z, which is non-zero. Find the two arguments of Z, I guess. I think so. For which the following equation is true. Okay, so let's see now. I think we might want to go with saying Z is... Now actually, I know it's not necessary to have the or here because the equation is cos theta plus I sine theta. Because what's going to happen is you'll get or cos theta plus I sine theta minus cos pi over 3 plus I sine pi over 3 times the conjugate, which is the or again, cos theta minus I sine theta equals 0. So you see the or didn't really matter. And I guess we couldn't even find the or anyway, so that's why they're only asking for the argument. So that's cos theta plus I sine theta minus, and when you multiply two complex numbers, you add the arguments, but this isn't in the correct form. Although what you can do is you can change that into minus theta because it's even, and you can change that into minus theta here and plus there. That's the same thing. So that becomes cos pi over 3 minus theta plus I sine pi over 3 minus theta equal to 0. Yeah, so that means the only way that this can cancel out is if pi over 3 minus theta equals 0, or I guess it could equal 2 pi as well. Oops. Because if this is 0, what will happen is the sine parts will disappear. Oh, sorry, I said equals 0, didn't I? That's wrong. That's wrong. I think it would need to, well, it could be 0. It would need to equal theta. Because if pi over 3 minus theta is the same as theta, then these negative cos's will cancel. Oh, yeah, and I forgot square brackets there. That whole thing is a negative. And these sines will cancel. That definitely gives me one angle. So that would mean theta is pi over 6. But what about a second possibility here? What about a second possibility here? Might have to, don't really want to, but I might have to use the formula book to combine these into a product, unless I can think about the other way that they cancel. Could might have to get the formula book here. Let's have a quick look. Let's have a quick look at those trig formulas for sum to product. Let's see. Or actually, I just feel like I need to add in a plus 2 pi, and that should do it. Because it's not that, yeah, I might not need the formula book. It's not that this and this have to be exactly the same. It could be like, for example, one of them is 10 degrees and the other one is 370 degrees. So the difference between them could be 0 or 2 pi. So you could have it like this: pi over 3 minus theta is 0 or is equal to 2 pi. So in that case, then you would get 2 theta equals pi over 3 minus 2 pi, which is pi over 3 minus 6 pi over 3, which is minus 5 pi over 3. So that means theta is minus 5 over 6 pi. But if we don't want to be dealing with negative angles, that minus 5/6 pi would be like about there. That is equivalent to, going this way around, which is 7/6 pi. So it's looking like I'm getting pi over 6 and 7 pi over 6. Now, where's my bag? I get the calculator out. Let's check something here. I have my calculator. I do. Let's just confirm that this works. So if I type in cos 7 over 6 pi and then minus cos pi over 3 minus 7 over 6 pi. Hopefully I should get 0. I do, good. And then let's repeat with the sine. Sine 7 over 6 pi minus sine pi over 3 minus 7 over 6 pi. Hopefully I should get 0 again. I do, good, good. So find two arguments for which that equation is true. I've just done that. Right, next now. Z equals x plus iy. Okay. 1, the modulus of z, that's equal to the square root of x squared plus y squared. Yeah, that's okay. Part 2, the modulus of z minus 3, that's the square root of x minus 3 squared plus y squared. And then number 3, modulus of z plus 1, ran out of space. That's x plus 1 squared plus y squared. Sorry about that, squished in. And yeah, I see why they're doing that. So they want us to solve the equation. So that's the square root of x minus 3 squared plus y squared is equal to the square root of x plus 1 squared plus y squared. So that means we have to solve x minus 3 squared plus y squared equals x plus 1 squared plus y squared. Well, we can cancel the y squared, so we're left with a quadratic. But actually the quadratic will disappear. X squared minus 6x plus 9 equals x squared plus 2x plus 1. The x squareds cancel. You get 8 equal to 8x. So that means x is 1 and y can be any value. So if we just mark off here 1 and I, the solution is this line here. And then we want to choose an element. So we'll choose, for testing, we'll choose z equals, let's say, 1 plus 2i. So the modulus of z minus 3, that's equal to the modulus of 1 plus 2i minus 3, which is the modulus of minus 2 plus 2i, which is the square root of 8. And likewise, the modulus of z plus 1, that's equal to the modulus of 1 plus 2i plus 1, which is the modulus of 2 plus 2i, which is also root 8. So they are equal. Solve the equation, indicate on the Argand diagram the set K, and choose an element and verify. Yep, okay. Looking okay. I think I've gotten everything in that question done.